Good evening. Welcome to Bzign Talks. Today's topic is energy efficient buildings design and analysis using BIM. We BIM Labs, situated in Kerala. We are Autodesk learning partner and also an IGBC member. We provide BIM trainings for students and corporate and also BIM implementation support for corporates and organization, BIM project outsourcing, BIM placement services. You can contact us through email, WhatsApp, Facebook, web, and LinkedIn through the displayed addresses. I'm Arya Shaji, Technical Engineer, BIM Labs, Engineering Services Private Limited. You can find me on LinkedIn or contact me through Gmail in the displayed address. Energy efficient buildings designed and analysis using BIM. A sustainable building is constructed of materials that could decrease environmental impact such as energy usage during the life cycle of a building. Building information modeling or BIM has been identified as an effective tool for the virtual analysis of a building's performance in the design stage to determine the designs that have the largest impact on the building's performance. Currently, there is an increased level of concern about the climate change effects and resource depletion issues around the world. The building and the construction sectors have been identified as one of the major contributors to the global environmental impact due to their high energy consumption. Energy consumption and greenhouse gas emissions to the atmosphere contributed to buildings are significant contributors to this environmental impact. The consumption of operational energy in buildings is identified as a factor having a single largest impact on the environment in the developed countries. Every building is made up of a series of components which have a role in thermal resistance and energy dissipation. The rate of energy dissipation in each of these building components depends on the design and environmental conditions. But due to their sensitivity to energy dissipation, the combination of all the components in the building and its envelope system need to follow a proportion to achieve a desired level of thermal resistance and operational energy consumption. Thus, the actions taken to promote the quality of buildings in terms of heat changes can lead to significant energy saving. Using appropriate thermal insulation can reduce heating and cooling loads that not only leads to a help to the family economy but also causes a reduction in greenhouse gas emissions by reducing energy consumption. The thermal building insulation materials and solutions constitute one of the key fields. Green buildings often include measures to reduce energy consumption. To reduce the thermal aspects of energy consumption in the operational stage, high efficiency windows and insulation in walls, ceilings, and floors increase the efficiency of the building. Reducing the use of operational energy should be the main concern of architects who wish to design and build green buildings. The most effective decisions related to the sustainable design of a building are those that are made in the pre-construction or construction stages. Obviously, decisions made after these stages lead to the inefficient and expensive process of retroactively modifying the design of the building to achieve a set of performance criteria. In order to realistically assess the performance of a building in the early design and pre-construction phases, access to the comprehensive set of knowledge of a building's form, materials, concept, and technical systems is required. Since building information modeling, BIM, allows multidisciplinary information to be superimposed within one model, it creates an opportunity for sustainability measures and performance analysis to be performed throughout the design process. Agenda: Introduction to BIM, Energy Consumption in Buildings, BIM Workflow. Energy consumption in buildings. Energy is required to keep the necessary activities and operating conditions as desired. Although the transportation and industrial sectors traditionally had consumed the most energy, buildings now rank among the highest consumers of energy due to increases in population, increases in demand for building services, and to meeting the desired comfort levels. Currently, buildings mainly use energy generated from non-renewable resources, and this usage results in the release of significant amount of carbon dioxide, which is thought to be one of the main greenhouse gas responsible for global climatic change. In order to reduce the energy consumption of buildings and its negative environmental impacts, such as global climate change, resource depletion, and reduction of biodiversity, it is critically important to use energy efficient technologies and approaches such as sustainable designs, energy efficient buildings, housing sustainability, the industrial building system, and waste management. Energy efficiency. The term energy efficiency means doing the same amount of work with less energy. It is a fundamental concept that can be used to save energy and reduce environmental impacts. Our main energy resources will eventually be depleted and it may not be possible to replace them in future. Although both energy efficiency and energy conservation approaches can reduce the emission of greenhouse gases, these two terms have different meanings. As mentioned earlier, energy efficiency means doing the same amount of work with less energy, but energy conservation means reducing the amount of work to save energy. R value is a term used to measure the component to resist heat loss through it. For example, by using energy efficient materials as the components of buildings, we can increase the R value of the components to prevent energy or heat from escaping while still benefiting from the same service. However, energy is conserved when a light is turned off. Although energy conservation should be taken into account, energy efficient technologies are a top priority because they can save energy and keep occupants comfortable at the same time. It means that the services does not have to be reduced to conserve and save energy. In addition to choosing the most energy efficient building components, we must also consider renewable energy resources to meet the energy demand in buildings in the future. And my efforts are underway in this direction. Non-renewable energy resources will eventually be depleted. We must focus our time and attention on the development of various renewable resources. By incorporating some proven technologies in the design of new buildings, significant quantities of renewable energy can be obtained and used. Renewable energy. The Earth's non-renewable energy sources are concentrated in a limited number of countries. The development and use of these resources could enhance the energy security by allowing them to rely on inexhaustible local resources while at the same time increasing their economic and social stability and reducing pollution and climate change. Full availability and daily continuity of solar energy shows that it demands more serious consideration. It is a free source of energy and it is clean and free of adverse environmental impacts. Building information modeling. The architecture, engineering, and construction, that is the AEC industry, has been seeking an effective tool for reducing cost and the completion of time of projects while increasing their productivity and quality. Typically, there are hundreds to thousands of documents for each project, and people must interpret the contents to tie them together. Effective coordination between design disciplines and communicating the design accurately to the field are constant challenges. Building information modeling (BIM) is driving a revolution in the construction industry. BIM involves the use of digital modeling software to design and manage projects more efficiently. It provides powerful new value to construction firms. BIM breaks down barriers between disciplines by encouraging the sharing of knowledge throughout the project lifecycle. Using BIM improves constructability and shortens the time required to complete the building project. In a BIM project, multiple documents are used in the traditional way. Instead, the building is built digitally as a database in BIM softwares. Instead of having a look at separate drawings, schedules, and specifications for information on a particular element, all information is built into intelligent object in the BIM model. In BIM, everything begins with a 3D digital building model. However, this model is more than just a simple geometric model that is used for visualization. A true BIM model consists of virtual evidence of the actual building sections used to create a building. These intelligent elements are the digital prototype of the physical elements such as walls, columns, windows, doors, and stairs. This prototype makes it possible to stimulate the building and understand its behavior before the actual construction begins. Of course, the most basic use of BIM model is for creating a realistic depiction of the planned building. The BIM model helps to design decisions by comparing various design conformations. BIM models contain more than architectural data since information about different engineering fields, sustainability information, and other characteristics can be easily simulated well in advance of the actual construction. As mentioned earlier, the data that is entered into a BIM model is during the design and construction phase of the building project throughout the building life cycle. The building related data can be achieved easily in the BIM for future usage, analysis, retrieval, and maintenance. BIM benefits in the design phase. The key benefit of BIM during the design phase is allowing the project team to make any changes to the project at the same time, which is very time consuming in traditional methods. By using BIM, various design alternatives can be evaluated and the most efficient design can be selected. Since the team members can communicate remotely, there is no need to meet with each other when collaboration is required. Also, all critical information is available, allowing members of the design team to make decisions more efficiently. Since changes can be made at any time, the members can spend more time on the design to ensure that it will be efficient and appropriate for the intended purpose. After changes are made in some part of the project, all other related parts are modified automatically. This is not the case in traditional design methods, in which all related parts must be modified manually, which is very time consuming. Since the entire project can be visualized, the entire project can be investigated, resulting in increased performance of the finished product. Using BIM will improve the project's design by reducing errors. BIM and sustainability. Evaluating the building's performance by using traditional tools such as CAD could be very time consuming and costly. One reason for this is the lack of strong and comprehensive database that includes all the data required to assess the building's performance. By having an integrated database of coordinated information, BIM is considered as one of the most effective tools for sustainable design. It could be linked to the performance analysis tools to access different sustainable design alternatives and to choose the most efficient alternative to the pre-construction stage. Recently, BIM has been used as a tool to achieve maximum sustainability on projects through energy modeling. For example, today, sustainability consideration require that we determine the most efficient and the best methods for designing a building, including its mechanical, electrical, plumbing systems, that is the MEP systems. In past, we had to use advanced calculations such as computational fluid dynamics, etc. Currently, however, with building information modeling and a tool such as Revit, we can use the same model for conducting geometric and energy analysis. Energy analysis tools provide the ability to conduct test runs and initial assessment studies. The most effective decisions related to the sustainable design of a building are those made in the pre-construction stage. So the role of building information modeling in achieving the most sustainable design at the time is critically important. Using BIM, the energy consumption of different material combinations for different parts of the building can be assessed before the construction phase begins. Thus, BIM can be used to determine the most energy efficient combination of build materials. When one is involved in the concept phase of a project, all of the different alternatives must be evaluated and tested in the conceptual design phase in order to understand the effect that each of them has on energy usage. Building performance simulation. A large portion of the total energy consumed annually is consumed by the building sector, and most of that energy is used for HVAC, lighting, and indoor air quality purposes. Therefore, buildings have a substantial role in the issue of environmental impact. Not surprisingly, though, building owners do not like expensive buildings and they try to reduce the cost of construction, the building by minimizing design costs, resulting in their paying much more energy in the operational phase. However, a building design that ensures a reduced operational cost can produce a more efficient building with a lower life cycle cost, even though the initial construction cost may be a little higher. After developing different types of software for simulating building performance, the members of the design team to spend less time for modeling and to spend more time focusing on various aspects of building, such as mechanical, electrical, thermal, etc. Using BIM as a tool in achieving sustainable design. If you focus on the significant element of sustainable design, we use that such a design requires the integration of all the building systems, such as its mechanical, electrical, plumbing, and architectural systems. When design team members are able to share their ideas among their colleagues using a 3D virtual model using a BIM tool, such as Revit software, true integration can occur and high performance buildings with long term stability can be designed and constructed. BIM has eliminated expensive and time consuming on site field coordination by providing an environment in which more accurate, effective, and helpful virtual coordination can occur among the members of the design team. All steps of modeling and analyzing a building for achieving a sustainable design are performed by BIM software. But BIM models also can be exported for usage in separate virtual environments for specific purposes related to sustainable design, which is a tremendous benefit to the design team in modifying and updating their models. BIM and energy analysis. The applicability of BIM in analyzing and reducing the energy consumption of buildings. We know that for its operations and to provide human comfort situations inside the building, it will be consuming a certain amount of energy. Energy efficient buildings are those which will be having less energy consumption. With BIM, we have to develop a sustainable building and we have analyzed an annual energy consumption value for the operation of the same. We will be developing the design options based on the lighting, shadow and sunlight exposure, and also we will be creating a solar panel visibility studies. The energy analysis of a building can be done at conceptual level, or we can do a case study on existing or ongoing projects, and we can evaluate the energy efficiency of the same. Regarding the workflow, at first, we will be creating a conceptual level climatic study on the considered project. Then we will be using BIM concept development tools like Formi 360 to do the same. The figure shows the platform of a Formi 360 software. And after that, we will be creating architectural and structural models. And we'll be also able to get the energy analysis, that is a sun and shadow analysis from the conceptual model itself. After that, we will be creating architectural and structural model of the project using BIM authoring tools. We can use Revit for creating these architectural and structural detailed models. Since BIM authoring tools enables us to input all the material properties and also the parametric properties that relates to the energy efficiency of a building, values like heat transfer coefficient and energy embedded value can be inputted over there in the model. After that, we will be pushing the model into a cloud platform called Insight 360, where we will be generating energy analysis result. After that, we will be evaluating the building performance result and design options. The energy consumption of a building will be calculated as energy usage intensity or EUI in kilowatt hour per meter square per year. Based on the energy settings of the project, EUI is calculated by dividing the total energy consumed by the building in 1 year by the total gross floor area of the building. The analysis report will have many design options like operating schedule, window to wall ratio, HVAC systems, building operations, lighting efficiency to alter and control the energy consumption of the building. In the screen, you can see a typical cloud-based energy analysis result. The analysis report not only provides us with the EUI of the project, but also energy cost of the project per total square meter per year. The main tools that we'll be using to complete the project will be Autodesk Revit, Autodesk Insight, and also the Autodesk Format. Autodesk Insight is a cloud-based energy analysis program which helps to improve energy and environmental performance throughout the building's life cycle by letting us integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. The BIM-based design and documentation system is ideally suited for delivering the kind of information that can be used to improve the design and performance of the building. So that's all about the topic. We'll provide a feedback form. Please fill that. And the certificate will be given by Autodesk. Autodesk certificates will be given. And we are providing a workshop for 3 days. It starts from 16th to 18th of December, and its cost is 1,500 per head. Next Bzign talk is on optimization of precast construction planning using BIM. And we have BIM communities on Facebook, LinkedIn, WhatsApp, Telegram, and Google Classroom. You can go for these links. Thank you. Any queries? The link for feedback and also the BIM community links are provided on the chat box. Please go through them. Thank you.